True projects. In this video, we are going to explain about cyber risk in Internet of Things world. Introduction. The project explores the significance of Internet of Things technology, which allows for direct integration of physical and digital worlds. IoT devices are employed in a variety of industries, including medicine, transportation, biology, and smart homes or cities. The initiative emphasizes the advantages of IoT, such as increased efficiency, accuracy, and economic benefits. The project does, however, address the issue involved with IoT, particularly in terms of security and privacy. The project's goal is to assess the security and privacy of IoT-based technologies in terms of cyber risk. Objective. The objective of the project is to identify the current security and privacy issues in IoT devices and propose recommendations for the solution of cybersecurity issues in IoT devices. The project aims to review the security and privacy aspects of IoT-based systems in terms of cyber risk. The main contribution of this work is to review the security and privacy aspects of IoT-based system in terms of cyber risk. The project emphasizes the need for proper security at the device level, application level, and network level. The project also highlights the importance of risk identification, assessment, and measurement in IoT devices to identify and countermeasure unauthorized access and control. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system Windows only, processor i5 and above, RAM 4GB and above, hard disk 20GB and above. In software requirements, we have Python IDEL with 3.7 version. Methodology. To implement this project, we have designed the following modules. The first module is Upload IoT Cyber Attack Dataset. In this module, the project starts by uploading the IoT cyber attack dataset, which contains data related to various cyber attacks on IoT sensor devices. The dataset includes information about normal traffic as well as different types of attack traffic. Second module is pre-process dataset. After uploading the dataset, the data undergoes pre-processing. This step involves cleaning and preparing the data to ensure its quality and consistency. It may include tasks such as handling missing values, removing duplicates, and converting data into a suitable format for analysis. Third module is Run Feature Selection Algorithm. Once the dataset is pre-processed, the next step is to select the most relevant features from the data. This is essential to avoid overfitting and improve the efficiency of the machine learning algorithms. A feature selection algorithm is applied to identify and extract the most informative attributes from the dataset. Fourth module is Run K-means clustering. After feature selection, the data is fed into the K-means clustering algorithm. This unsupervised learning algorithm groups similar data points into clusters based on their similarities. In this context, K-means is used to segregate normal traffic data into one cluster and attack traffic data into another cluster. Clustering helps in identifying patterns and separating malicious traffic from legitimate traffic. Fifth module is Run Random Forest Classification Algorithm. With the clusters formed by K-means, the next step is to apply the random forest classification algorithm. This supervised learning algorithm is used to build a robust predictive model based on the training data. It takes into account the features selected in the previous step and uses them to distinguish between normal and attack traffic. Sixth module is Predict Attack from Test Data. Once the random forest model is trained, it is ready to predict whether the incoming traffic is normal or indicates a cyber attack. In this module, the system processes test data, new data not seen during training, and utilizes the trained model to classify each data point as normal or an attack. Execution. For the execution of the project, we need to open the code folder. This is the code folder. This is the dataset folder. To implement this project, we have used IoT Cyber Attack dataset. Importing this dataset contains the information of source ID, source address, source type, source location, destination location, etc. This is the main code file. This is run.bat file. Instead of executing our project in the command line interface, we have created Windows bat file to execute the project. Double click on run.bat file. This is the graphical user interface. We have created this GUI by using the Tkinter library in Python. Using this GUI, we will interact with the project. Click on Upload IoT Cyber Attack dataset to upload the dataset. Select IoT Cyber Attack and open. We can see that the dataset is loaded, and the dataset contains numeric and non-numeric values, but non-numeric values are not accepted by the machine learning algorithm, so these non-numeric values must be converted to integer ID. That is, the data must be pre-processed. Now click on pre-process dataset to process the dataset. So here we can see that the dataset is completely processed. That is, the non-numeric values are converted to the numeric values. And after pre-processing of dataset, we will get the total records found in dataset and total features found in dataset before apply PCA feature selection. And in the square bracket, we have the different security and privacy attack found in dataset. Now click on Run Feature Selection Algorithm to run features. So here we can see the total features found in dataset after PCA feature selection, and the dataset is split into training and testing, where training will be of 80% and testing will be of 20%. Now click on Run K-means clustering. So in above graph, we can see same data are grouped into same cluster with same dots, and different data is grouped into different clusters. So in above screen, we got two colors, yellow and blue, where one color dot contains normal traffic and other color dot contains attack traffic. Now close the graph. Click on Run Random Forest Classification Algorithm to train dataset. In above classification graph, classification confusion matrix, x-axis represents predicted classes and y-axis represents true test classes. And we can see that in both x and y-axis, we can see values greater than 0, which means test and predicted classes are correct. And now close the graph. And here we can see the random forest accuracy. Now click on Predict Attack from Test Data. Select the test data, open it. So here in square bracket, we have the test data, and this test data is predicted as normal. So in this way, the test data is predicted as normal or anomalous data probing. Click on Exit. The final conclusion of the project is, the project concludes that the Internet of Things technology has transformed the worldwide network, but it also introduces various security risks. The study focuses on the security concerns, vulnerabilities, data manipulation, stealing, identity, device manipulation, and hacking related with IoT devices. The project makes recommendations for addressing cybersecurity vulnerabilities in IoT devices, such as proper security at the device, application, and network levels. The study underlines the significance of risk identification, evaluation, and measurement in IoT devices in order to detect and counter-react unwanted access and control. The report also emphasizes the importance of collaboration among many stakeholders such as vendors, manufacturers, and consumers in order to secure the security and privacy of IoT devices.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.